Good morning. Let's start our second session. Midterm 1 review part 2. Okay, that means yesterday we covered chapter 1. We talked about the different types of function, domain, and also limits and continuity, which actually this is the last question that we solved. We will start with similar question, and then we will jump to chapter 2 and we will focus on derivatives. Okay, let's do it. I will take my pen. If you have any question, if you have any exam review question, you may ask me. Okay, if you brought if you stuck with something, I can definitely help you. Okay? I will be more than happy. And as I mentioned yesterday, you may still use the discussion board and put some question. Okay, and the test will be open tomorrow. Okay, will be available. Okay, that means let's see continuity. Let's do this one because this question is similar. Okay, I was just a little bit like the word continuity is not really placed. It is placed in the answer. Okay, which means it's the same concept. But let's see, because in order to solve this question, we have to approach the same way like we solve the other one. Okay. For what values of the value of the constant c will the function f have a limit as x approaches 2? Because even if the function has a limit, we may have discontinuity. Yeah? We know, like, for example, I may have the situation like that, and let's say this is 2. Yeah? And let's say the limit is 1. As we can see, we have no value. Okay, but limit exists at 2. That's when we want the curve on the left-hand side approach the same value as the curve on the right-hand side. And we do have different curves. Okay? And actually, both of them are not defined at 2. That means definitely we have no value. But let's check the limits, and the limits are important. It means in order for the limit to exist, limit as x goes to 2 from the left-hand side must be the same like the limit as x goes to 2 from the right-hand side. And from the left-hand side, I will use the top formula. Can I squeeze that? C x minus 2 over x minus 2. And this one, I will use that formula. Okay, and actually both of the limits are quite good, which we can still practice the limits. Okay, because I can come back to the previous question from yesterday. Like, do you remember I even said, oh, the limit is no problem, like no denominators, no zeros in the denominator, no problem. That means I simply took 1 and substitute instead of x. But this one, I don't know if I can really take that right away 2 and substitute, because we will have sine of 0 over 0, which we know the property, right? We can use something, but it's 0 in the denominator and the same on the other side. 2 minus 2, 2 minus 2, 0 over 0. Okay? That means what is my point is, please do not substitute the 0 and like say, oh, the answer is 0, which is actually no option, okay? Or eventually you can choose the answer C. But please, okay, focus on the limits. That means let's compute the limit on the left-hand side, then on the right-hand side, and then eventually combine. Okay, which one we can start? We can start actually maybe on this side, the absolute value. First of all, I have to get rid of the absolute value. That means I will keep this, and we know if the quantity inside the absolute value is positive, that means if this quantity is positive, I can simply ignore the absolute value. But if the quantity is negative, like let's say -5, I can't ignore the absolute value, because then my answer will be negative. That means I can copy the same answer, I can take in the parentheses and put extra negative, in order to make quantity positive. That means let's investigate 2 minus x. X is 2 from the right-hand side. Can you give me the number 2 from the right-hand side? What will be the 2 from the right? Any number. Yeah, 2. Yes, okay. You know that you are in calculus class. 2.1, 2.001, okay. But if I substitute 2 minus 2.1 or 2 minus 2.001, am I getting positive or negative quantity? Negative. That means this quantity is negative. Then I will copy this quantity, but I will put extra negative to make it positive. Okay, and now we still have to do a little bit of algebra. I will distribute that negative. Negative 2 will, negative times 2 will be negative 2. Negative times negative x will be positive x. And I switch the order. Always when we have one positive quantity, one negative, we can place the positive as a first one. It's less confusing. Okay, beautiful. The same thing, the limit is 1. Very nice. Okay, but it's still, yeah, we have to check what is the value of c, yeah, because they're not asking us for the limit, they're asking us to find the value of c. Okay, now let's look at different concept. Sine of c times x minus 2 over x minus 2. If I substitute 2, I have 0. That means it's good. And 0 times c will be 0. Sine of 0 over 0, we know that this is 1. But what is important, we have to have identical 0. That means I have to see the same quantity. And what is missing in the denominator? The quantity we can see is just c. That means I can maybe put this. I will multiply by c, but since I am multiplying my denominator, I will also multiply numerator. Maybe I can remove that green, actually, because this was there. Okay, that's we know why we doing this. And now I will loop. This is my perfect property. Sine of c times x minus 2 over cx minus 2. And this quantity c x minus 2 is 0 at 2. Doesn't matter if it's from the left or right, it's 0. That means I have sine of 0 over 0. What this blue loop will be equal to? Can you tell me that it's 1? And then I still have the c outside. C times 1 is c. Or I can even write times 1. Okay. Oh. Okay, it's yeah, the final answer is 1. But of course, you know, if we will get, let's say, on the left hand side 2c or different value, then we still have to do like one few arithmetic steps. That's okay. The answer is 1, okay? Because the limit on the left hand side was c. Okay? But please do not assume right away. We had to complete the left hand side. Okay. That's limits, nice concept, but both of the limits are important, okay? Okay. Now let's jump to chapter 2, and we will start with this question. Yeah, I have just the graph, and we have to answer all of these questions. Okay, we have to say if the statements are true or false. That means the questions involves, of course, limits, continuity, but also at the end, a little bit of derivatives. But we know, looking at the graph, looking at the shape of the curve, we know when the derivative exists. And then we will talk about the calculation definition and calculation. Okay, statement A, the limit of the function f of x, and this is, of course, function f of x, exists at x equals to 2. Do you think it's true statement? What is the limit? What is the limit as x goes to 2 of the function? We can see on the left-hand side goes up, on the right-hand side goes up. That means I can say infinity. But is infinity like a a finite number? Do you remember? No, that means we will still say that the limit doesn't exist. I can still say D and E, which means the limit is undefined, as a finite number. That means this is the false statement. Okay, false. Okay, the limit of the function exists at 4. What do you think? I don't know if I can squeeze all of them. Yes, okay, that's I'm just reading. The answer is yes, and maybe I can put some values: 1, 2, 3, and 4. That means yes, is the correct statement. The limit exists, true, but can you tell me what is the limit? Just in case. The limit is actually 3. Because we're looking what the curve does, not the solid dot. That means that curve is approaching that open dot, which is at the level 3. Perfect. C, the limit of f of x exists at 6. What do you think? At 6, does the limit exist? Yes. Yeah, we have to. It's a weird shape with respect to the derivative, but limit exists. Function definitely does the same thing. Yes, I know. It could be because the limit, the curve on both sides approach that hole or that corner, and the corner is at the level 3. Yeah, this is true. And the limit as x goes to 6, it is also 3. Okay, now statement D. F of x has a jump discontinuity at 4. Do you think this is the jump discontinuity at 4? Does the curve jumping? False, of course. Thank you. We don't have jump discontinuity. We have, thank you, just one point is removed. That means not really jump, not jump discontinuity. We will have removable discontinuity because it's just one point removed. Doesn't matter if that point is above. Yeah, it's just one point. Okay, f of x has infinite discontinuity at 2. Infinite discontinuity, which we will expect that the limit, one-sided limit or overall limit, is infinity. Was limit at 2 infinity? Yes, true. That means we can say we have asymptote, we have infinite discontinuity. Okay, function is continuous at 6. Do we have continuity at 6? Maybe I can remove some. Okay, yes, because I saw, yes, we definitely have continuity, no problem. Functions continuous, no problem. Okay, now the last 4 statements. F of x is differentiable at 4. Does derivative exist at 4? What do you think? Not really. Because looking at the curve, at 4, I don't have the point. The point is removed. No point, no tangent, no slope, no derivative. Actually, I do have the value, but how can when I have the end point or one single point, I can't really draw a tangent. Yeah, it's not, it's not possible. Okay, that means we do not, function is differentiable, it is false. No. Derivative at 4 is undefined. No tangent, no slope, no derivative. What about 6? Is function differentiable at 6? What do you think? Also no. False statement, because we do have that sharp corner king cusp. I don't even know how we can call it, but yeah, it's the sharp corner. It's the same like the end point or like the one single point. I can't really draw a tangent. Okay, and then the statement I and J are a little bit confused, but let's answer them. Yeah? Let's answer them, because the above one, the previous one, is like they are typical. But let's see this one. The limit of the derivative, f prime, exists at 4. That means what this means, we have to think about the derivative and we have to check, how can I give you the hint? Or maybe you understand. Yes, it is true. Because what limit means like a function and let's say object or my item must behave the same way, in the same manner on the left and the right hand side at 4. And if we will think limit of the derivative, which means derivative must behave the same, for us, looking at the graph, derivative is the slope of the tangent. That we can see we don't really have I'm just looking, okay, we don't have a point, but talking about the limit, we don't really look at that point. We're just looking what is happening on one side and the other side. That means when I will draw a tangent here, I will have line like that. And if I will draw a tangent on the other side, I will have this, basically the same line, the same tangent, the same slope, the same derivative. That means this is definitely a true statement. Okay, like, do we understand? Because limit is giving me the option that we're not looking at that directly at that point. We're looking near to that point. And derivative, in this case, the slope, it's actually the same. And let's see if you can answer the last one. The limit of the derivative of f prime exists at 6. Do you think we will have the same tangent line on the left-hand side at 6? It's false. Okay, that means you do understand. Because we can see I can draw tangent somewhere really close, not at 6. But because at 6, we don't even have the derivative, but I can check near on both sides. I will draw one tangent and I will draw another tangent. Totally opposite. That means this one is definitely false, okay? Because it's okay, that means you understand. It's, yeah, the last two statements are a little bit challenge, but always when you think in terms of the slope of the tangent, you will be good. Okay. Okay, I have another graph. Let's skip it. I think we did answer this question because I just want you to tell me the numbers, the x values that function doesn't have derivative. That means this is function f of x. Actually, let's maybe do this. This is function f of x. We have to assume that this function goes to the infinity this way. And for what values of x, derivative is undefined. That means derivative will be undefined. And can you tell me what will be the x values? Let's start. The first one, I think we did answer. It's -2. Negative derivative doesn't exist at -2. What about the other one? I mean the next, after -2. -1, because we have infinite discontinuity. Derivative is undefined. Okay, another one. 1, really good. And then do we have one more? 1 and 2. And actually, do we have another one? Derivative is undefined at 3. Okay. And for example, we might ask you this. Derivative, let's say at 2. Oh, no, at 0. Derivative at 0 and derivative at 2.5. Which number is greater? Can you tell me? Derivative at 0. Oh, actually, that's, let me, because that's, no, let me change, because I want to confuse you more. Okay, let me, okay, let's say -0.9. We are really close to -1. Okay, derivative. That's mean which derivative, okay? I mean, yeah, which derivative at which point it's greater? Derivative at negative 0.9 or derivative at 2.5? Okay, that's mean derivative here, this will be greater. Okay, good. Thank you, Matt. And can we maybe approximate? We will not ask you to approximate, but just right now, just to have an idea. That's mean, what do you think? What's the derivative at negative 0.9? Actually, it's positive or negative? Maybe I can ask you this way. The derivative at, it's definitely positive because the point is somewhere here, okay? And we're looking at that slope of that tangent. That means it's huge. I mean, let's say 10, okay? Slope, positive 10. And what about the slope at 2.5? It's somewhere here. It will be negative and not so steep. I don't know, let's say -1. That means definitely, okay, definitely this is greater. Okay, that means if you will be asked on the test, like to compare the derivatives, always draw the slope. Draw the slope, and of course, if it's positive, negative, we know right away which number is greater. But if it's more steep and less steep, of course, the less will be less. Will be smaller. Okay, good. And then I do have all of these theorems. That's when we remember. I can tell you, you will not have true and false questions, but you know, just in case if you have to make some decision and answer the other questions, not directly the true and false. If f is differentiable at a, then it's always continuous. But if it's continuous, yeah, please remember it's not differentiable. And a good example is the corners, and especially the absolute value of x. It's nice and continuous function, but it's not differentiable. At 0, of course, at 0, at that point. Okay. And yeah, we know the options like the corner, discontinuity, or vertical tangent. Okay, please remember vertical tangent. We remember from yesterday, cube root of x has a vertical tangent at 0. Okay. Okay, let's answer this question. Which of the given function are not differentiable at 0? Okay, because okay, we have function f, function g, and function h. If you will see this question on the test, which function you will start with? Which function you will start to like analyze? Yeah, the easiest one. Which one is the easiest one? I think it's the g of x. Yes, Noah, thank you. Because this is the function from that, it's kind of like a parent graph, like a fundamental graphs. The graph looks like that. You can check the first 2 slides from this presentation. And of course, is this function differentiable at 0? Yeah, we do have a, no, of course not. You remember, you can find the derivative like algebraically, 2/3 x to the negative 1/3, and this is giving me the formula 3 cube root of x in the denominator. And the formula is showing me that we do not have, I mean, this fraction is not defined at 0, which means derivative is not defined at 0. Oh, that's g. G at 0 is undefined. Okay, that's me. I'm really solving the multiple choice option. We will analyze each function, but we can take the advantage. That means all functions, okay, A, it's still possible. G and H, G. That means we can definitely remove H, okay? Because we know that G, Which function is not differentiable at 0? I can check G. G is not differentiable at 0. It's like a negation. Okay, now function f of x. From lesson 1, I hope you learn how to, okay, first of all, for this type of function, the absolute value like of a little bit different things, more complex than x, I will recommend to draw a function. Then we will see right away. We can still do algebraically, but then we have lots of options. The quantity inside must be positive, and then we have to find the domain and compute the derivative. The quantity inside must be also negative, then we can compute the domain and indicate the domain and get the derivative. But graphing, we will see right away. That means in order to graph functions with absolute value, first, like the entire formula, because we can see the entire formula has the absolute value. First of all, we have to draw the function inside. And inside we have x squared parabola shifted 1 units down. Perfect. And that's the inside. But now we're taking the absolute value of this. That means absolute value of positive numbers are positive. Positive means the part above the x-axis. Okay, positive. But absolute value of negative numbers are positive. Oh, it should be more symmetric. That means we simply removing the negative part. We making like the reflection. Okay? From below, we project above. Okay, that means this is the graph. Should be nice, symmetric, but okay, that means what is happening at -1 and 1? Does this function has derivative at -1 and 1? No, because what? But we're not looking at -1 and 1. What about 0? Does this function has derivative at 0? Yes. And what is derivative at 0? Derivative at 0 means slope. It's of course 0. That means derivative exists. That function f is not my answer. That means I can remove this. Okay. That means now it's only g or h. And let's take care of h function. Yeah, h function, what we see? We definitely see different formula on both, the same formula on both sides of 0, but something different at 0. Okay? That means the value at 0 is 2. That means something like at 0, the value is 2, the solid dot. And now I have a curve on the left and the right hand side, and would be nice if the limit at 0 for that curve will be also 2. Then function is like smooth, continuous, and we will have derivative. But that means let's compute the limit, because I don't think this is the case, but you can probably, we have to check the limit at 0 of x squared sine of 1 over x. Do you remember the squeeze theorem I was showing you? Do you know that limit? This limit is, okay, we can use the squeeze theorem. Sine of any angle can be squeezed between -1 and 1. Okay, and then I will still multiply each part by x squared. -1 times x squared, the middle part, times x squared, and 1 times x squared. And as x is 0, parabola upside down goes to 0, parabola open up, it goes to 0, which means the middle function is also 0. Well, that means I think that function, I don't know exactly how the function looks like, but the limit, yeah, it's kind of like squeezing, because it's squeezed by 2 parabolas. It's open dot, but the limit is 0. That's we have discontinuity. When we have discontinuity, no derivative. It means function, last one, h, it's also not differentiable. Okay, It's good, yeah, good selection of function. Okay. Let's keep working. Let me skip this. Okay. We remember definition of the derivative. That was the old form, and we will focus on the H1. This is actually still definition of the slope of the tangent, but we know that that's the derivative. F of a plus h minus f of a over h. Or we can remove a and put x, derivative as a new function, which I think I have here. And that's what we have to know. Let's see. And for example, if function is equal to 1 over x, do you know the formula for f prime of x? The formula for the derivative? You may tell me right away, because I think I still took this question from section 2.2, which we didn't know the shortcuts. That means I place the formula. Oh, what's the derivative of the function 1? Oh, my writing. 1 second. Yes, because we can say this is x to the negative 1, and it will be negative 1 times x to the negative 2. And we can nicely rewrite, you know me, everything without the negative exponents. It's more like, yes, elegant. Yes, negative 1 over x squared. But what I did, I copy the expression, I copy definition, and then instead of x, I did put x plus h. Instead of x, I put x, which actually is the same thing. And then I did evaluate. You can check. The final answer is correct. Okay, that's mean now what's happened, because of course I have to create some questions, multiple choice questions to test your knowledge of the formula. I mean, for the definition of the derivative. That means what we can ask you. I can create question. Actually, I can show you. I can create this. Like I will create a fraction, and I will 5 of them. Only one is correct, and I can ask you which of these limits represents the derivative of function 1 over x. That means you have to just see that it's 1 over x plus h and 1 over x. That means we will have a function. Instead of x, we simply have to put x plus h and minus, copy the same function, and keep the h. And I will probably not ask you to go through to algebraically solve it, because you know the answer, okay? And let's see, I think I have, yeah, or something like that. We didn't even learn the exponential and logarithmic still, the formulas, that we don't even know. But what is the definition of the derivative for the given function? Okay, and you will see 5 limits, which actually I didn't type all of this here, but which one will be correct? And let's write down the correct. I mean, you have to write down this limit as h goes to 0, yeah, because that's definition of the derivative. F of x plus h minus f of x over h. And now the evaluation. H. And now, who can tell me, can you type for me, how can I replace this part? How can I evaluate this part? F of x plus h for our function. Function is sine of x over e to the x. That means instead of x, what we will do? Can you type? I can wait. Everybody can try. Okay, but can you type the entire function? Because I have to put the entire function here. I mean the form. Yes, that means this will be sine of x plus h over e to the power of x plus h. Of course, you will not evaluate. Yeah? And this one is just f of x. That means I can copy simply my function. But you can see for the first part, the first component is the function. Instead of x, put x plus h. Yeah? And then if I will, of course, because I did create another 4 limits which are wrong on your test, that means watch carefully. I might like miss h, or maybe I put x. Yeah, I make like, but look for this limit. Okay? And follow the formula. And I can give you like crazy formulas, but don't worry, I can give you, I don't know, x squared plus natural log of x, e to the x plus cosine of x. But what you have to just look, instead of x, remove x and put x plus h. That's the first box. Okay, minus just the original function. Yeah, that means that then I will know that you know the definition of the derivative. And of course, h in the denominator. And h goes to 0. Yes, please look at every single component. It's actually important. Okay, don't miss that question. Okay, and then I think we can jump to differentiation. Let's differentiate a few functions and we will be done. That's the formulas: constant, power function, constant times the function, addition, subtraction, product, and the quotient rule. Okay, and we also had trigonometric. Okay, sine, cosine, tangent, cotangent, secant, cosecant. We know all. We have to know. Yeah, and chain rule. Yeah? Differentiate the outer function times derivative of the inner function. The outer function still depends on the inner quantity. Okay. Okay. Oh, let's do this one. This one is actually still, I mean, it's the combination, it's the connection between the definition of the derivative and the shortcuts. Okay? That means if I will ask you this question, I will probably type a little bit more in the instruction. I will tell you this, that this limit represents the derivative of the certain function at the certain point. And let's answer this. That means, what do you think? This is derivative of the function at the point A. And G, looking at this, can you tell me what is the function? And what is the value of A? It's the, yes, 5th root of x. Excellent. Because we can see the x is replaced and a plus h is substituted. It's taking a place. And what is a? A is 32. Oh, excellent. And now, since we know that this is derivative at 32, and we can even see this is the value f of a, 5th root of 32 is 2. Okay, but we will, of course, not evaluate algebraically. We will be more smart and we will try to find out the derivative of this, then substitute 32, and that will be my answer. Okay, 5th root means x to the power of 1/5. Can you type for me what's the derivative of x to the power of 1/5? And I will write down for you. You're good, you're doing, yes, really well. X to the power of 1/5. You're probably typing, I hope. We have lots of students in the classroom. I would like to see everyone. Oh, I see some crazy answers. Some of them are correct. Okay, this power will become a coefficient, and then we have to subtract 1 from 1/5, which will be this. Yes. And I will rewrite this, of course, without a negative exponent. Denominator of this rational exponent is telling me what root to take, and 4 is actually a power, and I will keep outside. Now let's substitute 32. Of course, no calculators, but you can manage 5th root of 32 to the power of 4. That means what number to the power of 4? What is the 5th root of 32? 2 times 2 times 2 times 2 times 2 is 32. That means this is 2. Okay, 2 to the power of 4. 2 times 2 times 2 times 2, thank you. Still no calculator. And 5 times 16, 5 times 10, 5 times 6, 80. That means this is the final answer. Yeah, we can see like such a nice connection of the shortcuts and such a crucial and essential concept. Good. Okay. Please, yeah, if you will, but as I said, I will give you a little bit more instruction. You will not have this limited instruction. You will know what to look for. Okay, and now let's differentiate. Oh, okay. I have this question. I start with crazy one. Tangent cube of 3x. That means I believe we will use power rule, trigonometric function, and even the chain rule. Okay, and then we have to evaluate at pi over 9, which means we have to know some trig values. What I will do, I will write down, because the trigonometric, this is taken to the power of 3. That's the maybe, I mean, I think it's more clear notation than the original one. Okay, that we remember this is our u. You remember the inner function u. That means what's the derivative of u cube? Can you tell me what's the derivative of u cube? U cube. Yes, thank you, Chuck. It's 3u squared and follow the chain rule times derivative of u. Chain rule. And of course, we know what u is. Let's substitute because that's just the symbols. And I can maybe keep this and even give you that color. Okay, 3u squared times derivative of u. I can copy tangent of 3x derivative, and this is tangent of 3x. Okay, that means we will leave it like that, times, but we still have to differentiate. Okay, that means what's the derivative of tangent? Do you know the derivative of tangent? Secant. Secant square, and you probably Jack. Oh, no. Yes, we have to always keep the same angle, always. That means tangent of 3x will be secant square of 3x, and still we have another chain rule, the most inner function, derivative of 3x. I can maybe put right away, it is 3. That's we can see we actually have 2 times chain rule. We have power function and then trigonometric. Power is the outer cube. Trigonometric is the inner function, and the most inner is 3x. Okay, I will copy for you. Tangent of 3x squared. This is together. Okay, that means this is the derivative. 3 times tangent squared, and then secant square, and 3. And you may notice tangent of 3x, secant, I mean another trigonometric function of 3x, the original angle, the original input argument. We can't change suddenly. Angle is like untouchable. We can't like factor out, or we can't, I don't know, simplify. No. 3x was the original angle, and we have to end up with that angle. Okay, let's just substitute pi over 9, yes. 3 times tangent, pi over 9 times 3 is pi over 3, and secant square of pi over 9 times 3, it's 3, and I will put that square outside, and times 3, because I follow this. Okay, 3 times 3 is 9, but what is tangent? Tangent at 60 degrees, tangent at pi over 3. Can you tell me? Tangent at pi over 3. We have to know that value. Do you remember yesterday? I mean, you can quickly get the values of sine and cosine and divide, but it's worth to know it. One of the value, tangent for 45, yes, thank you, Matt. Tangent for 45 is 1, pi over 4. Tangent at pi over 6, which is 30 degrees, it's the smaller number, root 3 over 3. Oh, hang on, Matt. It's for the square root of, for the pi over 3 is just square root of 3. I'm sorry, I was just square root of 3 over 3, it will be tangent of pi over 6. Tangent at pi over 3, it's just square root of 3, because pi over 3 is like bigger angle than the, yeah, it's, no, it's, we still have time to make some mistakes and correct ourselves. Okay, 3. And secant, oh, what's the secant? Secant is the reciprocal of cosine. What's the cosine of 60? Do you know cosine of pi over 3? 1/2. Let's flip it. 2. Yeah. Okay, 3. Root 3 squared is 3. 4 and 3. 3 times 3 times 3 times 4. We can go 9 by 12. Is that the biggest number? It is 108. Okay. 108. Okay, that's me, not bad. Nice, also nice question. Okay, let's keep moving. Yeah, let's do this one. This question is testing the quotient rule. We have function h defined as a g over x squared minus 4. We have some values and we have to find h prime at 3. That means let's start with the quotient rule. Derivative of the top function times denominator minus top function times 2x, which is derivative of the function from the denominator, and denominator squared. That means that's important. And then let's substitute 3. G prime at 3, 9 minus 4, g at 3, 2 times 3, 9 minus 4 squared. And now it's just arithmetic. G prime at 3 is 4 times 5, 2 times 6, and this is 5 squared. Okay, 20 minus 12 over 25. Okay, nice number. But the top, the first step is important. Okay. Yes, let's do this one. That's another way to ask for the derivative. Find the slope of the tangent line for the curve to the curve x sine x squared at the point root pi 0. Okay, that you probably saw me like holding my breath because I was trying to say x times, and I will of course say now. Please remember, now I put the red dot, we will not see that dot. And we're not typing that dot. That means this is important to realize that we have to use, what rule we have to use to get the derivative. Product rule, of course. That means please remember. How can I, sometimes I can't. Okay, oh yeah, now I can write. Okay, that means x and sine of x squared. Derivative of x is 1 times the second function plus x, and we have to differentiate. Let me use this notation. We have to differentiate this function. First of all, we should note that sine is not squared. The angle is defined as a x squared. Okay, I will copy this. And now, who can tell me the derivative? Sine of x squared, sine of u. Okay, u means that we will add the chain rule. That means what's the derivative of sine function? Yes, that means we will have cosine of the same angle and times 2x. That's my chain. Follow the derivative of the inner function, which in this case is angle. Good. Please do not forget about this. Okay, and now we can substitute. This is still derivative of x. We can actually slope it's more appropriate the value, I mean the derivative at the given point. square root of pi squared, it will be just pi. This will be square root of pi, cosine of pi, and times 2 square root of pi. Okay, what's the sine at pi? Sine at pi is 0. Yes, we know how sine function looks like. 0, pi, 2 pi. It's, that's zeros. Sine of x. Okay. X and y. Okay, now I will put this. What about cosine at pi? Cosine at pi is, cosine looks like that. Cosine looks like that. That means this is 0. That's pi. That means the value of cosine will be, that's zeros. This is the value. Yes, it will be -1. The blue curve is cosine. I mean, I use the graph, not always. You may just look, picture in your eyes, in your mind, the unit circle. And 2 times this. Okay, that's what's the final answer. -2 root pi times root pi will give me pi. Okay, yeah. Good question. Remember about the product rule. Okay, and then I have 4 functions, 4. Let's differentiate this, and we will be done. Okay, cosine of square root of x over square root of x. We will use the quotient rule. Derivative of cosine is negative sine of the same angle times derivative of that angle. Derivative of the square root of x is 1 over 2 root x times the function from the denominator. That means this is derivative of the top function. I will need, and minus cosine of, function from the numerator times derivative of the denominator, which is 1 over 2 root x. Derivative of square root of x is 1 over 2 square root of x. And then denominator squared will be just x. Okay, let's simplify. What we will have? Actually, we will have negative sine, and I can't change and do the arithmetic on my angle, but I can combine these two. Maybe I can remove. I can definitely simplify, but I still have it. Okay, let's simplify this for now, which means I will have 1/2. And I will write this way. Actually, let's don't simplify, because you can see we can definitely do this blue, but I will put sine of root x and times that root x all over 2 root x. I will remove the blue, because normally I will simplify, but you can see I can't simplify this one, and I have common denominator. And because definitely your final answer will be, that means the whole numerator will have common denominator 2 root x and then negative sine root x. Let me put that square root of x in front. Okay. Eraser, that's square root of x and minus. And then minus cosine of root x. And I still have this one, but dividing by x means multiplying by the reciprocal. Yeah, I can do this way. Okay, that means I definitely simplify the double fraction. I only have 1 fraction bar, and I believe this will be the good answer. And then I have to just put 2, maybe x root x. Okay. Looks a little bit simple. Okay. Don't miss this question. Yeah, nice simplification. Okay. Another function, another quotient rule. This one should be a little bit easier. Derivative of x minus 1 is 1. times x plus 1 minus derivative of x plus 1 is 1. Actually, I can copy the function and times 1. And denominator squared. X plus 1 minus x plus 1. Please remember to distribute this because that's just the arithmetic. X and x is gone, 2 over x plus 1. Yeah, also nice function. And then 2 more. Tangent, that's the entire angle. We don't any product, that's not a product. Tangent of square root of cosine of x. Okay, let's start. The outer function is tangent. That means what's the derivative of tangent? Yeah, the outer function, tangent. Derivative of tangent is secant square, and I'm not saying the angle. You probably realize, thank you for typing. That means this is secant square, and what I will put here, because that's my angle, secant square of the same, right, the same quantity. However, follow the chain rule, times derivative of this quantity. Okay, that means we can copy secant square. That's done. Now, what's the derivative of square root? You remember me saying derivative of the square root is 1 over 2 square roots. 1 over 2 square roots, and also identical. It's the same like the angle. Square root of cosine, square root of cosine. And follow the chain rule, the most inner function. What's the derivative of cosine? Derivative of cosine is negative sine of x. That's when we actually have the chain twice. But you can see derivative of the square root is 1 over 2 square roots. And what we can do, we can simplify a little bit. I can put 2 square root of cosine of x. I can put negative sine of x in front, and then I have secant square of cosine of x. I was looking at that sine of x because I know that the angle is square root of cosine of x, but we do have cosine of x. That's the reason that we still have x. But original, for the most outer function, the angle was square root of cosine of x, which I have that angle. Yeah, I'm just checking if our answer is correct. Okay, I didn't miss anything. Negative sine of x. Each component, each part is here. Okay, looks crazy again, but it's nice chain rule. Okay, and the last, who can tell me the derivative? You can tell me and we will finish the session. Can you tell me the derivative of x squared sine of x? You can type whatever you like, and I hope it will be correct. Don't look at the other students typing, just find the derivative and okay, yeah, please, maybe almost everyone. We have more students. Okay, I see 2 options. I see okay. I have Jack, Kevin, and Chuck. We can wait. I can wait. I can tell you that we all make it. Noah, oh, no, you can't. You can't miss such an easy question. Okay, yeah, I see, because do you remember that red dot? Yes. Yes, you can. I wish to type the dot, but it will be, yes, we have to, yes. Thank you for, yes, because that's too easy for you to miss. You need that points, okay? And I know I want to do, yeah, that means please remember, please remember is that it's a product, and the product rule, we expecting the addition. That means I think math was giving us the correct answer. Derivative of x squared is 2x times the second function and plus x squared, and derivative of the second function, which is sine, is cosine of x, which I believe math gave us, yes, the correct answer. That means this is the correct answer. Almost nothing to simplify, maybe factoring out x. Okay, because that's nice and quick and easy question. Okay, and I do, okay, that means that's everything. And one more time before we finish, please check the sample tests, okay? Please go through your practice test. Of course, you will get some extra credit, and do not miss any question from these 2 sessions, which the slides are combined. That means you will have the notes combined. You will have 2 videos, two links for the recording, but you will have just one presentation, which is this one, because I was using the same one. And did I set up the discussion? Did I set up the discussion for this week? I think so. Or not? Let me quickly check. Because what I was going to say, you don't have to. Do we have the discussion? Oh, we don't. Okay, that means no discussion for exam. That means what I can do. Okay, we have Noise asking the question. Okay, let me just finish. What I can do, I will set up the discussion thread for the exam 1, and if you have some question, you can post. It's not graded, that because the other discussions, I'm giving you points, of course, towards the final grade, but I can set up the discussion thread. Again, I'm repeating myself, and you can type some questions, any question, and you don't have to like respond to the students you may ask. You may, it's not like the same type of discussion, but if you will post something on the discussion from now until Monday, I will give you extra credit. Okay, just typing, and maybe some students will ask the question. The only thing is you cannot ask the question from the midterm if you will take like earlier in the time window. Okay, but you may ask any question from the homework assignment, from the review, from my session, and I will also monitor. You may ask the question and I will answer also. Okay, and you will get 5 extra points. Okay, I will give you the extra credit. That means please use this. Of course, it's optional. And then, okay, then I'm reading the question. The big list of limits problems that you showed in the last lecture, is that available anywhere? I think it is posted in lesson 2. Lesson 2 was the limits. When you look at the module, lesson 2 is that list, and I think I even solve each question. Okay, I do have, I can come back. I mean, you will check in this presentation. I kind of, can you see, I circle 19, I will circle 1, I will circle this type, okay, the absolute, I mean the square root expression, and this one, absolute value, and actually this. Okay, I think like, okay, that means I did circle some of them that you should focus on. Okay, but of course for the practice you should go almost yes, almost all of them, but please check. I will double check. I believe it's lesson 2 because that was section 1.6, the limits, and I believe I solved the question and I scanned the page, and you can, yes, you can check this. Okay, and then, okay, we have lots of questions. And Dave is you answering, right? It's on the page of the PDF. Ah, okay. Okay, that means we have some answers. Okay. And Dave, there was an email from Emily saying that, Actually, right, because, oh, that's the, yeah, because I was trying to write the announcement after the session. Actually, Emily, for some reason, she left. I think she left the entire learning center. She will be not the GSG leader, the guided study group leader. She will be not working with us this semester. We do have a new person, but I believe the new person will start next week. Okay, and he will it's a man. He will introduce himself to you. He will send an email probably, but I can tell you that you will have no additional session. If you really like additional session, maybe over the weekend, please tell me, okay, and I can run, because I don't because he was just assigned. That's when he still is learning like how to navigate the whole dynamic of the course. But if you really need some extra session, like a recitation session, please let me know, and I will be happy to run over the weekend. Okay. Yes, but don't worry. Yes, I mean, even if Emily is not doing, you will have a new person, and he will replace Emily, and he will run the weekly additional review session. Okay, but please take the advantage of the chat of the discussion board. We can also communicate. But if you really like, I will be more than happy. Okay, okay. The test is open tonight. Okay. Whenever is your appointment, of course, you will take it, and you can still practice. And I wish you good luck with your review and the first midterm. Okay, and please stay in touch, but no exam question on the discussion board. Okay, thank you very much. Thank you. Thank you. You're such a good student.